pH of salt solution, that is also called as hydrolysis of salt. It simply means we are reacting a salt with water. So whenever a salt is dissolved in water, it's split up into the acid and the base from which it is formed. This process is called as hydrolysis of the salt. Hydrolysis is simply the process which is the reverse of neutralization. So what exactly happens? We have a salt which is Ba. So Ba is being formed from B positive and A negative. And the water contains H positive plus OH negative. Now what is going to happen is this cation which is H plus will react with A and they will form HA. Similarly, this OH negative will react with B positive and they will form BOH. So that's how they will form corresponding acids and base from which they are being formed. The next thing is the pH of the solution. Now the pH of the solution is depends on the nature of the acid and base from which the particular salt is dissolved. Means this is an acid. Is it a strong acid or a weak acid? Similarly, this is the base. Is it a strong base or a weak base? It depends on the nature of the salt and the chemical formula of the salt from which elements this salt is being formed. So the salt of a strong acid and a weak base gives acidic solution which is pH less than 7. Means suppose we have a salt which is ammonium chloride from which it is being formed. Whenever we will dissolve it, we will do one thing which is basically H positive and OH negative reaction. So H positive and OH negative from water will be there. So this H2O will give us H positive and OH negative. Similarly, this NH4 positive, NH4Cl gives us NH4 positive and Cl negative. Now this they will form HCl and they will form NH2, NH4OH. So that means we are getting a strong acid which is HCl. And the pH is going to be less than 7 because this acid is very strong, whereas this base is quite weak base. So that's why the dominance is because of HCl only. Hence the pH is going to be less than 7. The solution is acidic. So its hydrolysis gives us ammonium hydroxide and hydrochloric acid. Hydrochloric acid is obviously a strong acid, therefore it ionizes more or less completely, means it ionizes more as compared to ammonium hydroxide. Hence, the amount of H positive ion in the solution is going to be higher as compared to the OH negative ion. To give large number of H plus ions, where ammonium hydroxide again is a weak base, therefore it ionizes. Ionize means simply break down to a smaller extent, giving a smaller number of OH negative ion. Thus, as the number of H positive ion is greater than the number of OH negative ion, the solution is obviously going to be acidic only. The second one is the salt of a strong base and a weak acid. Now we are taking a strong base which loses more OH negative ions in solution than more H plus ion than this particular acid. Now how we are going to predict the pH? Obviously, as we have a strong base, it will release more OH negative ion. That means the pH is going to be more than 7. For example, we have a salt which is sodium carbonate Na2CO3. So again, whenever we are going to dissolve it in water, it basically hydrolyzes to give us sodium hydroxide and carbonic acid. So how we are going to do the hydrolysis? Simply we will do one thing which is H positive and OH negative will react with. So H positive will react with this CO3 2 negative and OH negative will react with this Na positive. So NaOH and we will get carbonic acid. And we know that this base is very strong. Hence, the amount of OH negative ion is going to be immense. So, sodium hydroxide is basically a strong base. It releases large number of OH negative ions in solution, whereas carbonic acid is simply a weak base. Hence, it releases a smaller number of H plus ion. Therefore, the solution of sodium carbonate is going to be basic or alkaline. The next is the salt of a weak acid and a weak base may give slightly acidic or slightly basic or sometimes neutral solution. So here we have in general Ba, which is salt of weak acid and a weak base. We are getting H2O, which is water, and here what we are seeing. Now what could be the example for this? So the example could be ammonium carbonate, which is here, ammonium acetate. Whenever these salts will dissolve in water, the weak acid and the weak base is going to be formed. So ammonium carbonate is NH4, this, and ammonium acetate is this. Ammonium carbonate is being formed from carbonic acid, which is again a weak acid. So basically, let me write it in a proper way. We can write it like this: CH3COO and then we will write this NH1. So this is how we can write. So these are basically the examples of salt which are being formed from weak acids and weak base. So here, whenever these being dissolved, weak acid and weak base are going to be formed. The pH of the solution basically depends upon the relative strength of the acid and the base form. If the acid is comparatively stronger than the base, obviously they both are weak. But there is relative strength, means if the acid is a bit stronger, means it is releasing a bit more H plus ion, then the solution is obviously going to be slightly acidic, means the pH is going to be less than 7, probably around 6.5 or 6.6. Also depending upon the number of H plus ions being released by that particular weak acid. But if acid is weaker than base, obviously the solution is slightly basic, means the pH is going to be a bit more than 7, which could be 7.5, 7.88 or less than 7.9 something else, depending upon the OH negative ions being produced by that particular weak base. So if an acid and a base formed of equal strength, mean the strength is equal, the number of H plus ions and OH ions are going to be equal, they'll neutralize each other to form water, hence the pH is exactly 7. For example, a solution of ammonium acetate, which is actually neutral. The salt of a strong acid and a strong base gives basically neutral solution. Obviously, when we have strong acid like HCl, whenever we are reacting it with NaOH, we will get a neutral salt which is NaCl. So salt of strong hydrolysis basically do not hydrolyze. Means whenever we hydrolyze them, they do not form basically their corresponding acids and corresponding base. They'll remain as it is in the form of their corresponding cations and anions. So basically they do not disturb the pH of water, which is 7. Hence in this case the pH is going to be 7 whenever the salt of strong acid and a weak base we have in the salt.